Yeah, thanks for the introduction. My name is Christine. I'm with the MicroPython team. And I would like to tell you a little bit about how MicroPython is getting ready for space at the minute. But first of all, what is MicroPython? MicroPython is about 6 years old now. It has been funded originally through a Kickstarter back in 2013. And there was some hardware developed, the PyBoard. So the aim of MicroPython is to run Python bare metal on a microcontroller, so you don't have an operation system like an RTOS, a real-time operation system off on the microcontroller in between. So you can use your Python knowledge directly on the microcontroller. So it's an open source project run on GitHub and has an the open source MIT license, which is very liberal, so you can use it for teaching, for your personal projects, or even in industrial use cases. There has been the BBC Microbit in the UK introduced to children, and they have been giving out 1 million and supporting the teachers there to teach Python in school. And these little devices run MicroPython as well. So how does this all work? So you can see on the left side there's the real evaluation print loop, the red box, the read evaluation print loop prompt, which is familiar to a Python programmer, which makes which goes into the lexer and produces tokens, which goes into a parser and produces a parser tree, which goes into a compiler and then produces the bytecode, which is then executed in a virtual machine. So this is just a little overview to how to get you on board, how this is going to work. But how is this going to be able for space use? Or how can this be used in space, or how does even somebody get the idea that there's going to be a potential for this? And the European Space Agency quite early showed some interest after the Kickstarter campaign and was thinking this could be a thing that we could put on the Leon Spark processors, which are on our space targets. So not programming them in C anymore, we could use a Python environment on ground and dynamically upload our code to the spacecraft. And there's also now just more recent a company named Spindler who is developing on these onboard control procedures. So originally, MicroPython was not intended for use into space. So the challenge here was, of course, there's the interest from MicroPython because the creator, Damien George, thought, of course I want to have MicroPython in space. That's amazing. And if we get it running in space, we have it so robust for any other kind of industrial product, and we get more of the embedded developers on board to try new things, so that they see there's not only C at the minute anymore, so you can use MicroPython, for example, for programming a microcontroller. But what is really important is it needs to be isolated from the onboard software that's running on a spacecraft, for example. There's no chance this virtual machine causes some threat or risk to the software that's running on the spacecraft. So it's not going to be, worst case, coming down. So this needs to be. It's very important that this certification gets ready. So the idea was porting to Leon 2 and Leon 3. And it helped to improve the MicroPython core. The aims of the European Space Agency at this point in time was they wanted to have a low use of the CPU and RAM. And also they wanted an interface to the native C code and other code that's running there. And it's on top of the real-time operating system that's on these microcontrollers implemented at the minute. There have been also some benchmarks performed with PyStone, which is a tool that that compares different Python implementation regarding their speed and space, so that low footprint and increased and low and high speed. And so again, the whole idea of getting MicroPython into space is the virtual machine and the compiler get separated. So only the virtual machine needs to be the certification, because it's quite hard when you have complex programs, and you need to ensure that they never fail. So getting a valid certification for it. So looking more into this, that was the idea what is coming next after this ESA project. There has been a lot of potential. There has been a lot of development going on regarding the robustness of MicroPython at that point in time. So the Spacebell, the Belgian company, decided to qualify an onboard control procedure engine, which is on top of the MicroPython virtual machine. So it's a product that's going to be sold by Spacebell, obviously. So there has been a contract in place with George Robotics, the company behind MicroPython. And it's going to be used in 2022 in the Euclid mission, which is a telescope in space. But so Spacebell was thinking, what are the most used scripting languages at the minute? So obviously Java, Lua, Ruby, or Python would be possible in general. Because when they were thinking about it, MicroPython, so this was 2.5, 3 years ago, MicroPython was not mature enough. So there has to be much more work put into. So they said, even though Python is the most popular and widely used language, let's make the first steps in Lua and see if we can use this as for our virtual machine on boards. But there was successful testing, but along the line, MicroPython. So they decided, let's continue the work what ESA has started, and we're gonna put more funding into MicroPython to make this a certified onboard control procedure engine. There are different ways to program these onboard systems. So, for example, there's dynamic linking, which means there's a compiled library which allows the onboard software that runs on the spacecraft that it gets to be extended. But the problem with it is that it runs on the same level. So if there's something uploaded and it's going to cause problems, it might interfere with the onboard software. So this is not recommended. Or there is the time and space partitioning, which would give additional security because you separate these things from each other. But and then this would mean that on the spacecraft there is already time and space partitioning implemented, and at the minute, so this is not always the case. So this leaves a lot of possibility to use interpreted procedures, which means they are uploaded, interpreted, and executed on the spacecraft. So on demand, on board, at any time when there's like a change or a problem that needs to be fixed. But usually scripting languages are compiled and executed on the same platform, but that wouldn't be possible because this needs to be separated. So technical and safety reasons make it basically impossible to do this on board. So the code is executed, so the code is generated on ground. So must be first compiled on ground and then uploaded. So again, what's an onboard control procedure? So it's a flight procedure to provide a flexible way to operate a spacecraft. It can extend the onboard software and modify the behavior of the applications up there. It's prepared on ground and dynamically uploaded even after launch. And it's written in a scripting language, compiled as bytecode and executed up there. So the whole procedure chain is, so you see in the blue button, it's the ground development environment, and the red one is the onboard execution. So you have your user language, and it goes to the ground development environment and produces the target bytecode. And of course, you can have a ground debug environment because there is no way you're going to debug it on the spacecraft. So when you write your Python code, it can be done in any standard Python development environment, and there is no dynamic importing. So the import expander allows the building a single onboard control procedure file, and it can import multiple files from each other. And as I said, you should be having your debugger environment on ground, because your code needs to be highly tested and debugged before it's going to go up there. So on board of the spacecraft, it looks like this. You usually have your target bytecode coming in, and your virtual machine is a C library, which is purely passive. There's only one access point. It executes your bytecode, and it's optimized for speed. So you have the telemetric and telecommand interface, and these are standard space to ground interaction, with an additional that you can upload it from a script as well. The storage handles the access of the memory and your onboard control procedure engine. So it's like this: the virtual machine can have several instances. So you can start, stop, resume, abort any kind of code you're gonna put up there as required from the ground. So this makes this all more flexible and interactive. So here I tried to make this come a little, so as an overview, if you want to go into more depth. So again, going back, so why would MicroPython be an ideal machine, virtual machine to run on board? So there's dedicated buffer for your Python stack and dedicated buffer for your heap. There's a garbage collector, and your heap can be locked, so it gives them the whole situation more security. The virtual machine is in Python 3.4. It's object-oriented. It has exception handling, math function, list, dictionary, binary, and what you're used to. So there's built-in imports and lots of built-in function, but external imports and most of the standard modules are not supported because it needs to focus on the things that has to be. Then there has been intensive testing, obviously. Is this really reliable and robust? So there are all relevant tests defined in the MicroPython virtual machine master branch. The CPython standard test suite for core Python language. And there has been end-to-end testing. So MicroPython script is produced and compiled. It's uploaded for execution in the MicroPython virtual machine, and the output is compared with the accepted result. Certification is oriented in the classical onboard software development process. It follows all these alignments. Space standards for category B software. And documentation has been made. And qualification status, I put in the ESA standards. So the conclusion of this is the new generation of onboard control procedure has been developed based on the Python scripting language, which you can use on ground to generate your script. And it's executed by the virtual machine on board in MicroPython. And well, we're very excited when in 2022 the first spacecraft will have MicroPython on board. So that's my talk, but I would like to invite you to the sprints on Saturday, because I brought some hardware with me to test out if you want to learn more about MicroPython, getting started, or see what we are what we are doing next. So it would be great to see you there. And if you have more questions, or you send me an email or contact us on Twitter or join the development on GitHub. Thank you.
Thank you very much, Christine. Very interesting. I thought that my weather station will be on the balcony, but in space it would be even more awesome.
Yeah.
I think there are questions. Yes. Running.
Hi.
Hi.
I was a bit curious, since this is compiled beforehand and run, I guess it doesn't really support metaprogramming then?
Not to my knowledge, no.
Okay. More questions here?
Hi.
Hi.
I'd like to know perhaps a few details. What do you control? Can you talk a bit about this, what it's connected to?
You mean on the spacecraft?
Yeah, on the spacecraft.
Okay, as I have to, it's not in space yet, so what's going to be, right? So the Euclid mission will be a telescope. So just imagine you want to adjust a mirror, and it seems to be easier to do this in a Python, easy on ground, and then upload it, and it's going to be executed in a sandbox safe environment and cannot hurt anything else that's going to go in this up there. Yeah.
Yes.
Thanks for the talk and congratulations.
Thank you.
Could you explain a bit more the safety considerations that force you to do compilation on the ground? Does that just mean outside of the microcontroller, or sort of necessarily offside of the spaceship altogether?
Yeah. So generally, any code can because you can't be really 100% sure you have no failure in your code. So that's the safety. So you want to avoid doing the compilation on the machine, because you want to avoid and debug it on ground before something happens. But I'm not sure if this answers your question. Or if you have, you mean the standards, or what's going to be following? So there will be, there's a white paper about this, so if you really want to dig into and what's...
Hello.
Hello.
Thanks for the talk. I'm really curious about the interaction with other C libraries. You mentioned something about maybe loading other, or interfacing other stuff that was already running. How easy or how complicated it is at the moment with MicroPython to interact with other shared libraries that are already in the microcontroller?
They are already in the microcontroller.
Or that you can ship with MicroPython itself?
Yeah, so in MicroPython in general, you can, so there's a C module, so you can, so MicroPython, you can interact with C language or assembler. There's even an inline assembler or something like this. So when you ask how complicated, well, the more experience you have, obviously, the easier it gets, but yeah. But that's the idea. That's why you like to have MicroPython, so you can use Python for all the easier or more obvious stuff, and then you go into the depth where you need a C library or assembler.
Hello, thanks for the great talk. One question, it's a bit stupid, but will the day come that MicroPython will replace the C and C++ for embedded programming or not? And if it will come, when?
Of course it will. No, that's an interesting question. I think maybe more like a coexistence for a while, because it's with MicroPython, for example, it's so much more easier to get people in than from the Python area or from high-level scripting languages in general. So, but still you have some where you really need the speed, or where you really need something special, which is your, special target. You might not be able to do this. But as more powerful as the microcontroller is going to get, maybe there will be one time. Yeah. A lot of people have said this when C came up, that it's never going to happen, that assembler is going to be gone, but that's the case, isn't it? Basically, most of it, not everywhere. It's not true.
Okay, so I'm interested regarding the boards that you will be using in order to send it to the space. What kind of boards? So I think like the ones that I use is the ESP8266.
Yeah.
But I don't know if it is like industry. So I'm more interested into what kind of boards that you can use reliably in the industry. And if it is reliable for a space, it should be reliable for the industry.
Yes, of course. Yes, of course. So
my next question is,
yeah.
I saw that there is CircuitPython.
Yeah.
And how it is related to MicroPython. Because I think there is. Yeah. So there is CircuitPython and there is MicroPython. How are they related?
Yeah. So CircuitPython is a fork, but a very closed fork from Adafruit. And Adafruit is manufacturing their own hardware. But they are using a fork of MicroPython to... So it's not really like... They are not separate. They are very close friends. And we work together to achieve common goals. But they are a little bit more orientated in, I would say, teaching and getting new people in. Which we would want to, but we try also a little bit with our new hardware line, for example, as well, really pushing this into industry development. If you have seen our new Pi boards, or come on Saturday, you can play around with them a little bit. So they are so small that you can embed this already in your industrial application, which is already in use with a few companies. So this board is ready for industry because it's used in industry.
And there was the first question about the boards. Yeah. It's okay? Okay. Any more questions? Then I have a question. My girlfriend is a teacher. Where can we buy these tiny, nice things? Is there a shop?
Yes, we have an online store on micropython.org. You can buy them there, or we have the distributors like
How much is it? A board.
This one?
Yes.
£35.
35.
Yeah.
Okay. Any more questions? Okay. Then let's thank Christina again.
Thank you.